Best girls in the school. Alright, boys. These are looking like pretty fine girls. Match them.
Down, Jamie. Make sure your feet are together on the line. Show me that you are ready to come inside. Showing me that you are showing me your razor sharp scientific focus. Great. Very carefully. Bye, Jamie. Great. Isaiah's tracking. Janae's tracking. So when you go inside, your thinking job is what force is acting stronger on the apple? What force is acting stronger on the duck? Which force is acting stronger on the apple? Which force is acting stronger on the duck? Great. Jared, what's your thinking job? Great. What is your thinking job? Let's hear it.
I think his job is what force is acting on the apple and what force is acting on the duck.
Great. Body track forward. Let's see who's ready to go inside, boys or girls. I suggest you two, if you do not want to get in trouble, you separate yourselves. Immediately. There you go. Great. Girls go in. It's on time to move inside. Nice, Madison. Good job. Keep it up, promise. Excellent work. Let's see who's going to come into maybe a fossil making time in that I'm doing with the first graders. Go ahead, Cassie. I know, I see it. You. Elizabeth is showing me her razor sharp focus. Nice. Cameron is tracking forward. Put it on my desk in the back. Really? Talking my rug? Correction. Great, I can tell that Cameron already has he's thinking about the thinking job. He's got a silent thumb on his knee. Oh, okay. Well, we'll do that, something about that. Nice, Gabriella has a silent thumb on her knee. I can tell Kasir has a silent thumb on his knee. His back is straight. He's tracking forward. Great, good afternoon, NYU Harvard. I got it right this time. Great, so which is the stronger force that is acting on the apple? Kimberly.
The stronger force that is acting on the apple is gravity.
Great, it's?
Gravity.
Great, what is the force that is the stronger force that is acting on the duckling? What's the stronger force? Kendall?
It is
The stronger force.
buoyancy.
The stronger force.
The stronger force is buoyancy.
Great, the stronger force is?
Buoyancy.
And we know because? How do you know? Isaiah?
We know because
Taja's hands are locked.
buoyancy
Janae's hands are locked.
buoyancy pick up things up and
What is that called when it's?
that
Buoyancy
buoyancy
makes items.
push up things and
Buoyancy makes items what? Sink or float?
items float.
Great, there you go.
And gravity let things
No.
let things sink.
Okay, so gravity makes something sink and buoyancy makes something float. So if the gravity is stronger, something will be pulled toward the center of the earth because that is gravity. It is Earth's gravitational pull. So the center of the earth is which way, up or down? Silent thumb. Jaden. The center of the earth.
I think it is up.
Agree, disagree. Daniel.
I agree with Jaden.
Really, the center of the earth is up.
I disagree with Jaden because
Rory, go wash your hands.
if the earth was up,
The center of the earth is down, and that's why things fall toward it. The center of the earth is down. The center of the earth is
Down.
So things fall toward the center of the earth, whether it be in water or whether it be in air. If it's buoyancy, buoyancy only relates to Water. So if you have something that is more buoyant and it pushes up, it makes that object float. It is pushing it away from the center of the earth. Therefore, it is the stronger force. Lock your hands. Great. Quickly promise, and then we have to move on.
When
Gabriella, can you turn the slide on for me?
when the apple it falls from the tree,
Good.
gravity is stronger because the gravity is like it's
Great. So, but the thing is there buoyancy right here? Why or why not? Would you find buoyancy right here today? Sean Sobers. Would you find buoyancy right there? Is there any buoyancy acting on the apple?
There's no buoyancy acting on the apple.
Why not?
Because
What's lacking? Why is there no buoyancy acting on the apple? What's lacking? Daniel's on a roll today. Good job. Elizabeth, today, let's go.
that the apple's heavy.
No, what is not present, which means there should be no buoyant force. Janae.
Gravity.
No, there is gravity. That's why the apple's falling. What is not present? Why is there no buoyant force? Go ahead, Jared.
It's no buoyancy because it's on Earth and no water or nothing.
Thank you. There's no water. There's no
Water!
Great, there's no water. So of course there can't be any buoyant force. Buoyancy only relates to water. Buoyancy only relates to
Water!
What do you think though there is? There's something else that is acting on the apple that is also weak. What do you think? Let's see. Bitta.
I think
Taking names for my time in tomorrow. If you did not get to go to my time in today, your name is still on the list, so I suggest you keep it together. What's acting on it? What is that called? Kendall.
air.
Air what?
Air resistance.
Great, it's called?
Air resistance!
Excellent work. It is called air resistance. Air resistance is acting on the apple, but is it strong? Do you think it's very strong? No, it's not. Why not? Why is it very strong, Fifi?
It's not very strong because
If air resistance was stronger, what would happen?
if air was stronger,
What would happen if air resistance was stronger? Mahogany.
if air resistance was stronger, it
Jazz, lock your hands for someone right.
it would not fall.
It would not fall, it would do what?
It will
It's the opposite of fall.
stay up.
Yeah, what is it called? It's the opposite
It
of
will
fall.
float.
Great, it would float, absolutely. Just like a feather floats down. What do you think is stronger, gravity or air resistance? Marquise.
It's air resistance.
Great, air resistance is stronger because the feather is floating. Just like when you are in an airplane, you are definitely using air resistance to your advantage in order to keep the plane up. Quickly, go ahead, Damon.
Also, like air resistance is kind of around us because we're
Finish that thought. Why would air resistance constantly be around us?
air resistance will constantly be around us because we need air to breathe and the air we breathe is kind of like the air resistance. So
Don't go too far off that. So you said air is everywhere, so why should there be... I just answered your question. So the reason why there's air resistance everywhere, just like Dewan said, we need air to breathe, therefore air is everywhere, and Jaden's tracking. Let's see, Elizabeth's tracking, Cameron's tracking. First tracking warning, Rory. So if there's air everywhere, there's air resistance wherever we go. You may not feel it, but if you start to move faster than the air particles, you will feel resistance. Jazz, quickly, and then we're gonna move on.
Also, as you said, when we're walking, we don't feel the air, but when we're running really fast,
You start to feel.
I feel the air.
You start to feel the air resistance.
I
Excellent.
hear it like going, like a groaning sound.
Or you hear it going past you like a whooshing sound. Absolutely. So that is the air resistance acting upon your ears. So the other day, Friday was atrocious, so I'll be doing the experiment for you in the front. Does shape affect gravity? Does shape affect buoyancy? It does affect gravity, but I want to know about buoyancy. Does shape affect buoyancy? What did we do on Friday? Yep, I see a lot of thumbs down, and this is why we need to do it again. Does shape affect buoyancy? Marlene?
Shape does affect
Speak up.
shape does affect buoyancy because when we did it like a cup shape, it depend
Gav Stewart, track.
The buoyancy was more.
Was the penny able to sink or float when we had the large cup shape?
It was able to float.
Agree, disagree. When we had the large cup shape, it was able to float. Great. I'm going to go ahead. I'm going to test that theory. Right. So she says, according to her, if I have a large cup shape, then my penny should be able to float. So here I have some water. And here I'm going to do it for you. So, silent thumb, should this shape be able to float my penny? Why or why not? What do you think? Let's see, who haven't I heard from a lot today? Gabby S.
I think if you put the penny in the bowl, it would float. Cause last time when we did the other shapes, it didn't work.
Why didn't the other shapes work?
Because
Go ahead, Cameron Bailey, why didn't the other shapes work?
the other shapes didn't work because because we already know that the other shapes can already sing.
Go ahead.
Because the size affect
Not the size,
the weight.
right? Not the weight, because remember, we already did that experiment that said size did not affect buoyancy. Because some things were big and floated, and some things were small and sank. Kassir,
That size affects buoyancy.
I want.
No. A shape affects buoyancy.
Great. So Marlene is saying with this broad shape, this broad cup shape, that Janae's tracking. Great. Kimberly's tracking. That my penny should float. So do we agree or disagree? Great. Drop and lock. So Duan, everybody else that you're trying to get their attention is tracking me. You need to join the party. I don't know who you keep looking at over here, but their eyes are on me. They're trying to mess around with you. They're trying to learn. What happened? What happened? Did it float or did it sink, and why? Daniel.
I said it float because when you made the cup shape and when you put it in first, you was testing it out, see if it float. But when you put the penny, it didn't sink with the cup shape you made.
Great. So did the shape make the buoyancy stronger? Silent thumb. Why? Gabby G.
It does because when you put the penny in, it doesn't sink.
Great. Okay, but think about the shape. Is the buoyant force stronger with a wider shape? Think about surface area. Silent thumb if you've ever heard the word surface area. What do you know about surface area? Let's see. Jazz.
I know that surface area is that
Gigi, straighten your back.
if you know what the surface is, and then it's an area.
Okay. So I want to show you a picture, and this will help you learn about surface area because this will help you to understand exactly why certain shapes have more buoyancy attached to them. So, which do you think has more buoyancy? Which do you think has more buoyancy and why? Where do you think the buoyancy is stronger, Jared?
I think the one on the right side is stronger because it's a bigger size, and the other one is shorter, and I think if you put that one, the left one in the water, it'll kind of sink.
Okay, so let's try it. So absolutely. So this shape corresponds to this shape here. As you see, there's more buoyant force, there's more surface area for the buoyant force to push up on. But what happens if I decrease that surface area? Is there more buoyant force? Is there more surface area for the buoyant force to push on? Nice, Rory, he's online. Go ahead.
I say no because if it's like this and before when it started like
Daniel, keep up the good work. Put it away, don't let me see
when
it.
it started like this with the penny holding it in the cup. But if it's crinkled up, it's not gonna have more surface area because it's.
And if it has less surface area, does it have more or less buoyancy? What do we think? Promise.
I think
Thank you.
gonna have less buoyancy.
Great. If it has less surface area, it has less.
Buoyancy.
If it has more buoyancy, it has more what?
Surface area.
Yeah, nice. If it has more buoyancy, it has more surface area. So when we drop this in, you will see it's not as much surface area, therefore it will sink. Great.
No, it's
It's floating a little bit. It's floating. Oh.
Yeah, there you go. Great. So what you're going to do, you're going to go back. We are going to be at 0. You're going to draw the 2 shapes that I showed you here today. I can even keep them on the board. You're going to tell me which one. Oh, you're going to tell me. Great, bring it back. 3, 2, 1. Nice. You're going to tell me which shape floated and which shape sank. It is very simple. You're going to draw the shape. You're going to tell me, did it float? Did it sink? It is in your data packet, which is back at your table. If you're number 4, want to get ready? 2, stand up. Okay. Swiftly, simply, silently go back. Great. What you are going to do is you're going to pass out the packets. No, not on the table. Nope, don't touch the ones on the table. Pass out the data packets. Great, Sean, go. You have 1 minute. We're going to go back. We're going to be at 0. Then we're going to come back, and our next experiment is we're going to try to figure out, does mass affect buoyancy? But first, we need to know what mass is. So I already see some silent thumbs up. We have some hypotheses. So, silent thumbs up. So, Dewan, what do you predict? Track Dewan.
I predict that mass is like depending on like how heavy a shape is and how.
Right, shapes aren't heavy.
I mean.
It's okay.
How heavy objects are.
Uh-huh.
And how
Nice job, Cameron.
Like how
So
weak objects are, like how.
Good job, Sean. So
how
the question was, though, you're telling me about mass, which is great, but the question is, does mass affect buoyancy?
Oh, I think mass does affect buoyancy.
It's okay. It's a hypothesis. What is it?
I think mass does affect buoyancy because a lot of times I like to do things.
Let him finish.
And I like to do a lot of things. And then one time I had something like, well, it was like a medium size, and I put it in my water, and then the thing that I put in my water, it sunk.
Okay. All right. Interesting. All right. Did it have a lot of?
Buoyancy was not stronger than the mass.
Okay, so the gravity was stronger. So what we're going to do, okay, so that's great what you think, but that's not what we're going to do right now. We're going to finish, does shape affect buoyancy? Then we're going to go on to mass. Are you ready? 2, stand up. You're going to go back, lock your hands, eyes on me, waiting for further instruction. I really suggest that you do, it's all right. I really suggest that you go back and you follow instructions. I will know because I am recording the class. 3, go back. Nice, Don. Great tracking. Good job. I gotta add some more names to my fossil making assignment tomorrow. I hear noises. I'm trying to figure out why. They belong in the center of the table. Great. Everybody open up to does shape affect buoyancy? Go. Okay, so just move it. Is that so hard? It's not that hard. Paper's not going to move down to the table. Testing shape. You have testing shape. It's right there. Great. Kasir's showing you that he's ready. Nice, Cameron showing you that he's ready. So what you are going to do, everybody point to the shape column. Whatever shape you have there, you will erase it. All right? It is erroneous. You're going to draw the first shape that is on the board, which is my narrow shape. Go. 0 noise. Take a pencil. If somebody else grabs the same pencil, you will grab another one. You will take another one. There you go. Sharing, please, and thank you. You learned all this in kindergarten. So just simply draw the shape in the first. If you need to erase anything, go ahead and erase it. Nope. Is that the shape I have on the board? Jaden, time in for tomorrow. Azan is sitting all the way on his chair. Gigi is sitting all the way on her chair. Good job. Go down to the next row. Draw the second broad shape that you see on the board. Nice. Sorry. Great. Now I have done the experiment at the front. Everybody point to the sink and float column. Okay. For your first shape, did it sink or did it float? Write it down. If you have something there, erase it. That was from Friday. So you did not do that correctly. Janae, help him. No. You have nothing drawn. I don't know why you've been sitting there. Once you have that done, then you can think about using that bathroom. Elizabeth, you can use kind words. Yes. That's why we're doing it now. Sean Sobers, we have some scholars at your desk that need some help. Go ahead and help them. Great, nice job. Cameron, time in. Great, that was super simple, very simple. What you're going to do is form your conclusion. We're going to come back and we're going to share out. Conclusion, no, zero noise. Your conclusion to the question, does shape affect buoyancy? Looking for some great conclusions. Who's going to lead the discussion in the class today? 2 minutes. A lot of you need to fix your chart. Remember, this one was the one that sank, this one was the one that floated. Yes. So why were you hitting his pencil with your pencil? Does that make any sense? So you need to apologize. Go get his pencil. No, Asia should get it, thank you. They give you a sheet right there. Keep working. About 30 more seconds. We're going to come to the road and we're going to share out. Pencils up. Nice. Put them away. 5, 4, 3, 2, and 1. Marlene's back is straight. Sean Sober's back is straight. Azan's back is straight. Showing me great focus. Showing me great effort. Come on, get ready. 2, stand up. So far, so good. Let's see. We got 2 scholars who are going to share out. Swiftly, safely, silently. Run spots. Great. If you have a share card, hold it up. Okay. Gigi, come up to the front. Gigi, does size affect buoyancy?
I think size does affect buoyancy because the shape that
Jaden's tracking. Daniel's tracking.
it was
Jared's tracking. Rory, you
it
have a
was a
tracking direction.
small shape, but it sunk. But most small shapes float, and this big shape over here floated, even though big things might sink.
Okay. Well, she said big things might sink. Why is that not necessarily true? What experiment did we do that said that showed that size doesn't affect buoyancy? Go ahead, choose a scholar.
Binta.
We did the testing size.
Okay, but what did we do when we tested size? How did we figure out that size does not affect buoyancy? Give me some examples. Think about some of the. Oops, gonna spill this. Think about some of the things that we use. Why does size not affect buoyancy? Isaiah, track Isaiah.
Because
Size does not affect buoyancy.
size does not affect buoyancy because
Janae's back is straight. Tasia's back is straight.
the cone is big and it sink. And also that when we use
Rory's hands are locked.
one of the
Think about it though. Use 2 examples that we used when we were doing the sink and float, when we were dropping the objects in the water. Think about size. Why does size not matter when it comes to buoyancy? Let's see, is it still silent thumb on the knee? Okay, why don't you choose a scholar and ask why does size not affect buoyancy? 3, 2,
Size does not affect buoyancy because
Janae's tracking.
when we came into class, the cruise ship floated.
Think about what an experiment we did in class. What did we do? Dagatigi. Does size affect buoyancy? Think about 2 items that are, one is large and one is small, but one floats and the other one sinks. Go ahead, Daniel. Daniel.
that with the size does not affect.
I know, but I want to know why. Okay.
Because
1, 2, 3, eyes on me.
1, 2, I
I have 2 items. Which one sinks and which one floats? Promise.
the marble sinks in the ping pong ball floats.
Which one is bigger, though? Silent thumb. Which one is bigger? Is on.
The ping pong ball is bigger, so if a bigger object is going to float and a small object is going to sink.
Great. So does size affect buoyancy? Silent thumb. Great. Size does not affect buoyancy. You could have something that I could put a beach ball, which is much bigger than this marble, which is still going to sink. Silent thumb. Which is still going to sink. The marble is still going to sink. So size does not affect buoyancy. But does shape affect buoyancy? Thank you, Gigi. Have a seat. If you have a share card, hold it up. Come on up. Great. Does shape affect buoyancy, Jared? What was your conclusion?
Mine's shape does not. Does affect buoyancy because if you have that little shape like it was in a little U and you put the penny in, it has sink. And then when you put
Promise
in
is tracking. Gabby's tracking.
The big shape, and then you put the penny in, it has floated.
So I did change the shape. I changed it to a broad shape and the penny float. And if I changed it to a narrow shape, the penny sank. This is why boats have the shape that they do, right? Because, all right, Promise and Dewan. Promise. Speak.
The boat, when we was doing that experiment, the cup shape, it was bigger. It was bigger than the penny, but it wasn't heavier than the penny, and the penny was still floating.
Okay. Go ahead, Dewan.
If you go back where there was
Go ahead,
a
Jeanette.
little U shape, they the little U, like the skinny U shape,
Uh-huh.
it sunk. It sank because
It sunk.
it sunk because it sunk because it had a little amount of surface area, so that gave the buoyancy like.
Was the buoyancy very strong?
No,
No,
the
no.
buoyancy wasn't
But
strong.
what about with a larger surface area? Can anybody help Dewan finish his sentence? A larger surface area means that is the buoyancy stronger or weaker? Jazz. Oh no, actually, Kasir.
The buoyancy is stronger.
For a larger surface area, why?
I think that because large things they float since they're
Nothing.
large objects float, but small objects sometimes some small objects can sink and some can float sometimes.
Okay, excellent. Good job. So Jared, what was your conclusion about does shape affect buoyancy? And ask a scholar who agrees or disagrees with you. Go ahead.
Mine was that
Nice and loud and proud.
shape that shape does affect buoyancy
Great.
because when we had the U shape, the short one, it had sinked, and then I said that when we had a big U shape, it had floats
Mm-hmm.
because the surface on the bottom it had a kind of U shape that can float.
Great, excellent. Good job, Jared. Thank you. Have a seat. So what we're going to do is we're going to go back. We are going to see whether size. We're going to see, now we know size does not affect buoyancy. We know that shape affects buoyancy. Now we're going to see if mass affects buoyancy. I went back and I decided to weigh all of the items that we have been using, and I found several different masses. Now, we use these masses in grams. We use them in grams! They're called units. If you see, each number has a G behind it. What does the G mean? What do you think it means? Go ahead.
Grams.
Say it louder. The G means?
The G means grams.
Great. Make sure, no more bathroom. Make sure that you are always writing the unit. Just like if you go over to the south side and you start to study with Miss S and Mr. Herman, they really want you to use units because it is very important. You can't just put a number because they do not know if you're talking about grams or pounds or anything else. Degrees, meters. You have to put what you are talking about. Great. So, number 4 is pass out the work that is in the middle of the table. Go. Number 4 is wake up. Not right now, we're going to go back to our table first. Nope. Great. You're going to go back, you're going to write your first name and last name on the top of the paper. When you're ready. 2 stand up. So if we safely silently go back, I've got another starburst I gotta hand out. Let's go. I hear speaking and I do not know why. Nice, Isaiah is tracking, Gigi is tracking. Go ahead and write your first name and last name on the top of the paper. If we have a problem taking pencils for ourselves, like 2nd graders, you will have a correction. You'll learn how to do it after school. Okay. Oh, okay. Thank you. Nice. Good job, Promise. Good job, Isaiah. Nice job, Azan. I have to add more names to my list. Really? You just totally ruined it. Great. What's 3 as a me? So what you are going to do first, go back in your packet. You do not need to ask anybody else. You do not need to look at anybody's paper. You have this information. Everybody point to where it says, everybody point to where it says hypothesis. Right? A neat and complete hypothesis. I want to see who's going to share how. Does mass affect buoyancy? Go. Isaiah is working hard. His back is straight, thinking about what he's going to do. His back is straight so the oxygen can get to his brain. Marlene's back is straight. Great, Azan's back is straight. Draw sober, straighten your back. Elizabeth, you're at 0. You have 3 minutes. Yep, thank you. Daniel, time in. Place. Effect. That doesn't make any sense. I think mass effect buoyancy, I'd say that because this goes up, this pulls up. I don't know what you're talking about. Go ahead and get that $5. That's a good hypothesis today. Let's see if everyone else does. Okay, but tell me, how does that relate to mass effective buoyancy? About 16 seconds. What do you mean by mass? Pencils up. 6. Put your pencils away. 5. Nice job, Devon. 4. Good job, Thomas. 3, 2, 1. Negativity on the pressure. Right. Really? Is that what you do? So you have a correction. That doesn't make any sense. It's okay. Can you put that back where the crayons are in the back? Thank you, Maury. If you were number 4, go ahead and put away the work. Everybody else, want to get ready? 2, stand up. Did a lot of moving around today. Good. Swiftly, safely, silently, red spots. Let's go. Looking for the best sport. Looking for the best transition. Great, let's hear some Now, before we actually move on, one thing I did not go into was what is mass? What do we think mass is? What is mass, Kendall?
Mass is like weight.
Okay, so the problem with that is it's very similar to weight. Usually the more mass something has, the more